This is Linear Algebra 2.2. Previous video we discussed about metric operation. So this section we gonna study inverse of metric. Let's talk about inverse metric, guys. Before we talk about inverse metric, I give very simple example of multiplication and inverse of number in multiplication. For example, guys, 3 times 1 over 3 is gonna be 1. So this rotation, guys, when you see this one, another way write down this one gonna be 3 negative 1. So we call inverse of 3 in multiplication, guys. So metric, you thinking about metric, same number of row and column, n by n matrix. A is invertible, meaning is you're gonna find any other metric B, same size. This one is n by n. A times B, B times A is identity metric. Guys, identity metric is diagonal entry is 1, other side is gonna be 0. So B gonna be we call inverse of A. B gonna be rotation is a negative 1. That's inverse. Then when you're talking about inverse metric, you're gonna thinking about A times B, B times A is IN. Another way you write it, A times A inverse times A gonna be identity metric. That's the definition of inverse, guys. So this section, we're gonna find the inverse metric of 2 by 2 metric. That's very simple. The way to find the inverse metric, guys. Let's practice the metric A has inverse metric. How gonna show B metric is inverse. B metric gonna be inverse of A metric. So we have to show A times B, B times A gonna be identity matrix. What is dimension? What is the size of metric is 2 by 2. So that's gonna be I2. I2 meaning is guys diagonal metric gonna be 1, 1 and 1. Every other entry gonna be 0. That's what we have proved. If you prove A times B, B times A is identity metric, we're gonna say metric B is inverse of A. So let's practice this one, guys. Okay, multiplication of two vector. Let's go. First row, first column. Negative 14 plus 15. First row, second column, negative 10, positive 10. Second row, first column, 21 minus 21. Second row, second column, 15 minus 14. So simplify 1001. Oh, this is I2, dimension 2 identity metric. So one more time, we're going to try this one, but generally speaking, guys, A times B identity, B times A is identity too. But let's practice it. This one, first row, first column, negative 14 plus 15. First row, second column, negative 35 plus 35. Second row, first column, 6 minus 6. Second row, second column, 15 minus 14. So you have 1001. So what your conclusion about this one is, you're gonna say B metric gonna be A inverse of A, or A metric gonna be B inverse. Okay, so we're gonna say A inverse, A gonna be identity matrix. So the big question is how gonna find inverse matrix when you given the matrix? Practice here, guys, but generally speaking, 2 by 2 matrix, it's very easy to find inverse matrix. So here is A matrix gonna be 2 by 2 matrix, guys. Here is 2 by 2, 2 by 2 matrix. So first we're gonna define the determinant A matrix is, determinant A meaning is AD minus BC. That's going to be, we call determinant AD minus BC. First condition is determinant A is not 0. That's very important. Then you know metric A is invertible, which meaning is metric A has inverse metric. So how can find the inverse metric, guys? Inverse of A gonna be 1 of determinant A. Determinant A we define AD minus BC. Simply memorize AD cross and cross, okay? DA, you switch to this part, then change the sign, negative B, negative C. That's how to find the inverse metric when, if metric has 2 by 2 metric. But another big thing is here, determinant A is not 0. Oh, we called about determinant A is not 0, right? That's invertible. Determinant A is 0, which meaning is A is not invertible. Another way is say A does not have inverse metric, okay? We could not find the inverse metric, okay? 2 by 2 metric is much simpler than other size of metric, guys. So let's practice this. So this one gives the 2 by 2 metric. Can you see that 2 by 2 matrix? We want to find the inverse if A is invertible. How can check A is invertible? First, guys, you have to check the determinant A. Determinant A definition is AD minus BC. AD, D, here is gonna be, here is A. This is B. This is C. This is D. So crossed. 2 times 1 is gonna be 2. Minus 3 times 0 is 0. That's the 2. 2 is not 0, right? So 2 is not 0. So A is invertible, which meaning is A has inverse metric. So second is we want to find the inverse metric. So 1 over determinant A, DA, switch it. And negative B, negative C. Very simple, huh? So determinant A gonna be what, guys? Determinant A, we already find the determinant A is 2. So this one gonna be 1 over 2. What is D value is 1. What is A value is 2. B value is 3, negative 3. C value is 0, that's the 0. So that's the inverse metric of the A. So you times 1.5 each entries, that's gonna be 1 over 2, 1 over 3 over 2, 0, 1. That's the inverse metric. Okay? So first you have to check determinant, very important. Then determinant cannot be 0. That's gonna, you can find the inverse metric. Okay, practice. Pause the video, try to by yourself. Did you find the inverse metric? Let's check determinant A, right? So you see this one gonna be A, this is B, this is C, this is D. So determinant A gonna be AD, 4 minus 4 equals 0. What are you gonna say? Determinant A meaning is A is not invertible. Okay, so we cannot find the inverse metric. All right, so next video we're gonna find the inverse metric of general metric.